Hi all, welcome to Clear and Concise. Let's have a look at this question. Here function f is given which depends on two variables x1 and x2. We need to find stationary point for the given function f in terms of c. A function is said to have a point which is called as stationary point if its first derivative at that point is equals to 0. That means the rate of change of function f with respect to its independent variables at that point is 0. Physically, a function is said to have horizontal tangent at stationary point. If a function is having horizontal tangent at any point, that point is called stationary point. Stationary points are very much useful in optimization problems in order to find extreme points. In the sense, in order to find minimas or maximas of a function, we will use stationary points. Now let's find stationary points for a given function. As the function is multivariable, we need to equate the derivatives of, that is partial derivatives of each independent variable, that is dou f by dou x1 equals to 0, which yields derivative of function f, which is cx1 square plus x2 square minus 2x1 x2 minus 2x2 with respect to x1. That yields derivative of x1 square is 2cx1 plus derivative of x2 square. As we are finding derivative of function with respect to x1, we need to treat the other independent variable as constant. So derivative of x2 square is equals to 0 as x2 is constant, minus x2 is constant and 2 is constant, taking out and finding derivative of x1. Derivative of x1 with respect to x1 is 1, so it yields 2x2, and here 2 is also constant and x2 is also constant as we are finding derivative with respect to x1. So the derivative of constant is again 0, that is equals to 0 here. The equation reduces to 2c x1 minus 2x2 equals to 0. Let's assume this as equation 1. Now find the derivative of function, partial derivative of function with respect to other independent variable x2 and equate it to 0. That yields dou by dou x2 of cx1 square plus x2 square minus 2x1 x2 minus 2x2. Now as we are finding derivative with respect to x2, we have to treat x1 as constant. X1 as constant. That yields derivative of c is also constant, x1 is also constant, so derivative of x1 square is 0 plus derivative of x2 square is 2x2 minus, here 2x1 is constant, so taking it out and finding the derivative of x2 with respect to x2 yields 1. So derivative of 2x1 x2 is 2x1 minus derivative of 2x2 with respect to x2 is 2, that is equals to 0. The equation reduces to 2x2 minus 2x1 is equals to 2. Rewriting this as 2x1 minus 2x2 equals to minus 2. We obtain this by multiplying with minus both sides. Let's assume this as equation 2. Now solving both the equation, that is 2c x1 minus 2x2 equals to 0, 2x1 minus 2x2 equals to minus 2. In both the equation 2 is there both the sides, so reducing these equations yields cx1 minus x2 equals to 0, x1 minus x2 equals to minus 1. Subtracting equation 2 from 1 yields, here minus, this is plus, and here also plus, minus x2 plus x2 gets cancelled. Now x1 if we take it out, c minus 1 is equals to 1. That yields x1 is equals to 1 by c minus 1. 1 by c minus 1. Now substituting 1 by c minus 1 in above equation yields x1 minus x2 equals to minus 1, where x2 is equals to x1 plus 1, that is equals to 1 by c minus 1 plus 1, that yields 1 plus c minus 1 divided by c minus 1. 1 gets cancelled. Now x2 is equals to c by c minus 1. So the correct answer is option D. We have x1 as 1 by c minus 1, x2 as c by c minus 1.